Hello everyone, this is Xiao from Hunan University. I'm honored to be here and make this presentation. The topic of our project is mainly about using crowdsensing on shared bikes to collect air data. As the pictures shown below, shared bikes are booming over the world. These mobile platforms provide a nature, scalable, and ubiquitous solution to carry out IoT devices, especially appropriate for tasks which have short-term and geographic demands within a certain range, such as air quality monitoring. There are several challenges when we design our system. The first one is how to deploy geographic dense measurements which are microscale size. Secondly, how to reduce the measurements errors on IoT sensors employed by mobile crowdsensing. And the third is how to exploit collected data to infer the air quality status on the data points without measurements. In our project, we did some research on related works as below. Here is a system overview of a mobile crowdsensing system. We name it UbiAir. It is designed within a mobile crowdsensing framework and implemented as a novel client-server system following the sharing economic paradigm. UbiAir contains three modules, which are data sampling, data calibration, and data analysis respectively. This is a diagram of our data sampling module. According to the spatial precision of air data we want to reconstruct, the space would be split into grids within specific density, and we deployed the read envelope, namely rewards, to motivate users to collect the data at crucial grid points. For the user ends, we implemented our mobile application for users to interact with our system server. Users can simply get it by scanning the QR code on the shared bikes. A hard calibration part to obtain a well-trained model. The relationship between the measurement of low-cost sensors and the expected calibration measurements is decomposed into a linear part and a non-linear part. Then a software calibration part. In this example, we estimated the data at points S0 without data, based on the data along a certain trajectory around. Then the S0 would be calculated with different formula according to whether it is an emission source point or not. We proposed an adaptive Bayesian compressive sensing model to reconstruct the data into fine grains. In general, it contains three phases, which are sampling, recovering, and reconstruction, respectively. See the paper for details if you are interested. This is the formulas about selecting projection adaptively to get the reconstruction data. Simply put, it greatly takes the current estimated variance as the criterion to optimizing the read envelope deployments. By embedding our sensors box and its power system into shared bikes, we verified our UbiAir system initially at our university. Here and above are the comparisons between sampling maps and reconstruction maps after BCS approach in the same monitoring area. We can see from them that the data reconstruction maps presents smoother color transition than the data sampling map, and the grid scales at the same position present similar colors among these heat maps. Here we conduct several experiments on external factors to help us to set proper parameters in our project. Then we compare our hardware and software calibration methods with other methods. Overall, both of them present better performance than other methods. In order to evaluate the efficiency of our proposed adaptive BCS algorithms on data recovery, we compared the adaptive BCS with other three methods. Furthermore, we studied the relationship between the number of models, input data, and the reconstruction error by comparing adaptive BCS with the other three methods. To sum up, UbiAir is lightweight, low cost, accurate, and scalable system, presenting promoting performance and usability on combined mobile crowdsensing with sharing economics for fine-grained air quality monitoring. For future works, we might extend the estimation to be an online operation for the cases without positioning signals, and design better rewards to encourage users to upload collected data immediately. Additionally, we could use blockchain to protect user privacy. That's all. Thanks for listening.